1988 with the second-class upper division. Due to his insatiable quest for knowledge, he later enrolled at the Federal University of Technology, Futmina, to complete an NSE degree in Industrial Production Engineering. Still not satisfied, he moved to Nottingham University, Malaysia campus for his doctorate degree in Manufacturing Management. During his PhD, he focused on lean manufacturing with particular attention to Toyota Production System, TPS. He investigated how different leading space agencies are using elements of TPS in the management system in comparison to NASDAQ. In his work, he postulated a model referred to as lean management hybridization, in which NASDAQ's management could hybridize lean management with organizational culture for better efficiency. Before joining NASDAQ, he had several years of experience in the upstream sector of the petroleum industry and the steel company. He worked extensively on pneumatic valves, pumps, compressors, and similar mechanical equipment used in that industry. He was the Deputy Director, Quality and Infrastructure Management Division in the Engineering Space Systems Department of the Space Agency until he was promoted to the position of Acting Director, Center for Space Innovation and Development, CSID, popularly known as the Incubation Center of NASDAQ. And now he is the Director, Substantive Director of the Center. He is currently the Substantive Director of the Center for Space Innovation and Development located here at the NASDAQ headquarters. He is married and blessed with wonderful children. Distinguished guests, ladies and gentlemen, it is my pleasure to present to you for his keynote address, Dr. Haruna Mohammed, at this event. So highly welcome, sir.
The cream, in the profession of engineering, of which it's going to consume a lot of time if I'm to begin to the fundamentals of engineering. And the delivery has to do with, from these rudiments, where we are today in Nigeria, the challenges and where we're supposed to be. The written and printed document looks bulky because I have references, but I'll try to do justice to it and try to achieve this in good time. So I'll read directly from my lecture notes, to make it quite explicit. The title, Actualizing Engineering Concepts and Principles Through Innovation and Development, the Case of Nigeria. Engineering principles are ideas, rules, laws, standards, processes, regulations, or concepts that need to be considered when solving an engineering problem. Engineering concepts and principle is the fundamental approach taken in developing and making any products and service for societal benefits. Engineering products and services emanate from the applications of principles and concepts of physics, fundamentally, because that's the origin of engineering. For instance, engineering mechanics, engineering quantities, static and dynamic laws in the form of force, speed, acceleration, work, energy, etc. are applications in mechanical engineering, while electrical circuits, electrical quantities, circuit concepts, engineering. Engineering principles transcends quality, standards, processes in the form of testability, maintainability, integrity, external integration, ethics, management, etc. However, there is no one specific list of engineering principles that fits all definitions, since the concepts used to solve a problem will often be different depending on the type of problem encountered. Beyond problem and standards, depending on the problems, under scrutiny. There's a general saying that keep it simple is an engineering principle, especially in design and manufacturing. What that is trying to say is that make it simple such that your customers can understand it without any complexity. And there are so many. But what we are trying to say here is taking it from the perspective of Nigeria itself. Nigeria is the largest economy in Africa with gross domestic product GDP of $406 billion and an estimated population of over 200 million, which is expected to grow to 400 million by 2050. Nigeria is the seventh most populous country in the world after China, India, United and Brazil, respectively, and currently maintains economy on the continent. The IMF predicts that Nigeria's GDP will hit $574 billion at the end of this year. This is to be achieved, through engineering applications, because that's the basis for production vis-a-vis development. This is ascent, and the consequent birth of Economic Recovery and Growth Plan, ARGP, by the federal government of Nigeria was published in February 2017, with a focus to make Nigeria globally competitive by investing in its people in order to have her share in the then knowledge economy. Going by the industrial developments, from the first industrial revolution, the second, the third, which is around the knowledge economy, now we're in the fourth. The plan therefore recognizes the importance of science, technology, and innovation, STI, across all sectors in the economy. Here, innovation is described as new creations or new ideas in the formulation of products and services. It can also be an incremental development of existing products, processes, services, or approach in formulation of new products and services. Technology, therefore, is the agglomeration of the above principles and concepts through innovation in the creation of products and services. Already looking at it from the top, it means be it development itself, technology itself, the innovation itself emanates from the application of the principles of engineering and concepts. That's what we're trying to say here. At present, the world is reaching the end of the deployment phase of the age of ICT and starting the installation phase of a new paradigm involving frontier technologies and sometimes called Industry 4.0. That is the fourth industrial revolution. There is no doubt that ICT deployment resulted in an enormous concentration of wealth in the ownership of the major digital platforms like Microsoft, Facebook, Twitter, WhatsApp, transforming the social medium of interaction around the globe. Western Europe and its offshoots like Australia, Canada, New Zealand, and the United States, along with Japan, have pulled ahead with this trend of technological change. Nevertheless, a few countries, notably in East Asia, such as China, Singapore, Thailand, etc., are subsequently able to catch up through technological learning and imitation, which we here refer to as technology transfer and innovation. Most other development countries, such as Nigeria, remain on the periphery. I mean, this is obvious. We don't need to overstress this. But the big question now is, how will the fourth industrial revolution, Industry 4.0, affect Nigeria? Much will depend on whether we are catching up, forging ahead, or falling behind. In all modesty, our national policies and our involvement in the production of products and services with favorable international trade balance will go a long way to solve part of this problem. But first, we must identify our challenges. Our challenges goes forth. These are challenges that are impeding the rates, the level, the speed at which we embrace, technology, technological development. First, we have this weak, financing mechanism. Weak financing mechanisms. Nigeria's research and development R&D expenditure is still relatively very low compared to those of the developed country. The financial mechanism is still poor. For example, the African Union has established a target of 1% of GDP, but an average of sub-Saharan African countries are still under the 1%, about 0.3%. This is very little. There is very little private funding. One of the major areas that we have to look at is if you have international exposure, you would observe that most R&Ds are being funded by the private sector, not necessarily depending on government. But here, we don't even have the private sector's interest in this area, so it's a major challenge. Slow diversification. Nigeria's approach in emulating industrialized countries by diversifying its economies, absorbing and adapting new technologies for local use is extremely slow. Lower technological and innovation capabilities. Nigeria have fewer skilled populace and dependent to a large extent on agriculture, which tends to be slower to take advantage of new technologies. Well, the population is high. If you take an empirical research, survey, you relate our population to our level of education in general, we're still behind. Now, come to talk of in engineering, we're still far behind. We still need more people to come on board so as to achieve this. Demographic changes. Nigeria typically has an expanding younger population, which will increase the supply of labor and depress wages, reducing the incentives for automation. The government might not encourage automation because we have so much population with less, skills to go into automation, and the fear for what happens to the excess population of the youth, is a challenge. Intellectual property rights and technology transfer. Stringent intellectual property protection would restrict the use of frontier technologies. that could be valuable in sustainable development goals, related areas such as agriculture, health, energy. We need to relax some of the stringent laws and regulations to encourage, at least if we get to a level, it's like, if you start a program in a university, the standard is rated very high, but when you get to a level, you need, to lower or level the standard so that everybody will be carried on board. Now, overcoming these challenges, to overcome these challenges, governments, those things government should do, or what we should do, so as to alleviate these challenges. To overcome these challenges, governments and the international community need to guide new and emerging technologies so that they support sustainable development and leave no one behind. From the outset, it will be important to establish ethical frameworks, very key, particularly for the deployment of all products. Many voluntary initiatives are already aiming to ensure that the processes and outcomes are fair, transparent, accountable, and inclusive. Government should try to foster supportive innovation ecosystem. We at the Innovation Center, since we are within the ecosystem, there exists this ecosystem, but we believe that we could still do better. We are not doing enough, and that's about an avenue for us to propagate and proclaim the technological advancement. Based on assessments that analyze different techno-system paths and their impact on inclusive and sustainable development. An example of an international organization which assists such is the United Assist with such